Lesson 3.1, Solving Linear Systems by Graphing. A linear system consists of two separate equations. A solution of a linear system is an ordered pair xy that satisfies each equation. So the solutions are intersections. In Algebra 1, we talked about having one solution, infinite solutions, or no real solution. And today we're going to be looking at some different names for those same classifications. We will be looking at three different linear system outcomes, and you'll see that I have a place for three graphs. So the first graph I have marked as consistent, and the second graph I have marked as consistent. And that means that we're actually going to have solutions. So for the first graph, if I have I'll draw two random lines, and they're going to intersect at a point. The intersection, or the solution, the ordered pair, looks like we went over 2, up 1. It's independent because we have two separate equations that would create the red line and the green line. If we go to the second graph, again, it's consistent, so we're going to have solutions, but it's marked as dependent. And it's dependent because we have two equations that are just different forms of one another. So this one would result in two lines that are actually going to be on top of one another. So we could graph one equation, and then the second equation we graph would end up with the same exact points. And so that results in infinite solutions. An example of two equations that would do that would be, so if I started off with two equations, y equals negative 4x plus 8 is already in slope-intercept. My second equation, 8x plus 2y equals 16, if we subtract 8x from both sides and divide every term by 2, we end up with y equals negative 4x plus 8, which is what my first equation was. So you can see we started off with two separate forms of the same equation. So that's why we have infinite solutions, and it's called consistent and dependent. Finally, we have no solution or inconsistent, and that's because we're going to end up with parallel lines. So if I graph my two lines, they will never intersect. So there's no solution. There's never going to be an ordered pair that would be a solution to these. An example might be y equals 1/2 x minus 7, y equals 1/2 x plus 4. So if we have parallel lines, we have the same slope, and we can see that once we have them in the same format. And here they're in slope-intercept. So to recap, consistent is when we actually have solutions, and then independent versus dependent. Independent, we have two totally different equations. Dependent, we end up with the same equations. And then for inconsistent, it means that we don't have any solutions because the lines are going to be parallel. So my linear system consists of these two equations. We're going to graph them and decide if they're consistent, inconsistent, dependent, or independent. So y equals x minus 1 is already in slope-intercept, so I'm going to leave it. But we're going to have to rework the second equation. So the first thing we're going to do is try to isolate the y by subtracting 3x from both sides. And then we're going to divide everything by 2. Every term is divided by 2. So y equals negative 3/2 x plus 3. So now I have my two equations, and we're going to graph. So we start with the y-intercept, -1. And my slope is 1, so we could use 1/1, 2/2, 3/3. Those are all forms of 1. So I'm going to go rise over run up 2/2. And then I'm going to use negative. So I fill up the graph on the beneath it. I'm going to go down 2, 1, 2, to the left 2. 1, 2. And then I'll connect them with a straight line. Now we're going to graph my second equation. We start with 3. Rise over run, so it says to go down 3. 1, 2, 3, but we go over a positive 2. 1, 2. Connect. And it's not asking me for the solution. It's not asking me for the XY value, the ordered pair. It's just asking if it's consistent or inconsistent. So it's consistent because it has a solution. And then it's independent because we have two separate equations, two very different equations. And that's it.